All right, everyone. Today we're going to be talking about constraints and relationships. So, all constraints and relationships, or all constraints, excuse me, actually is kind of like a check, right? And remember in Python and OOP, we created something called getters and setters, where we wanted to make sure that only specific information was being set to an attribute inside of our object or inside of our class instance if it met specific standards. Well, that's what our check or our constraints are going to be doing as well, right? It's only going to accept specific data if it meets a certain set of standards. So we already had something like that yesterday, kind of working in the background. When you create an integer, right? If you try to pass a letter into an integer field, uh, Postgres will check that constraint. It'll say, hey, this isn't a type, that's a number, and it will throw an error, right? Now you could pass numbers into strings, and we'll go into talking about how to handle some string data here today. With that said, let's move into some of our constraints that we'll see commonly. So there's a couple of real world scenarios here on our lecture today, but we're just going to go straight from top to bottom. Let's talk about students, right? So here I have a constraints.sql. What I'm gonna make is, oh, not a class, excuse me. I'm gonna go ahead and drop table if exists. I'm gonna call this one students. Then I'm gonna go ahead and create the table students. All right. So the very first thing we always throw into a database is the ID, which in this case, we're using serial primary key. And then we have a student name, and I'm just gonna go ahead and name this one name. Oh, I can't do that. Which is going to be a varchar of, let's say, 200, or just to match what's on the lesson, we'll go with 255. But here we can see that we're already using some constraints, right? Our primary key is a constraint. When we set something to a primary key, that means that it is going to be unique every single time it is created. And because we added this serial portion, it means that it won't ever be repeated. So there you go. We have a primary key that can be referenced to for this one specific instance or a record that's being added for this table. And we know that it's going to be unique and it won't ever be repeated because we have a serial primary key. Now for our varchar down here below, well, our varchar will interpret all input as string, right? So I could put in something like 678, and when I pull that out, it won't come out as a numeric number of 678. It would come out as a string of 678, right? Just like as if I try to put in something saying that this is true, well, rather than saying, hey, this is true. So if I try to pass in T for true, well, what it would actually return is a letter T for true, right? So we know that there's other type of entity fields that we can use to accommodate for these things. But know that if you set something to varchar, it's going to be able to accept all of your input regardless of the way you put it in. It's just going to interpret it as a string, right? So that's a different type of, I wouldn't necessarily call it a built-in constraint, but just know that that's its functionality that comes from that entity field. Does anyone have any questions about serial primary key or varchar? Okay, well, let's start adding a couple of more constraints here, right? Well, what if we had an email or a student email, right? Let's follow our naming convention since we started this way. This would also be a varchar. Let's go ahead and give it the max capability here of 255. But also, usually emails should be unique, especially student email, right? Well, we've seen the unique constraint being applied automatically through the serial primary key, but how do I apply it to something that's just a varchar? Well, I just simply add the word unique. And this tells my program that this is going to be a unique constraint, meaning that if I try to add two students with the same email, it will fail. All right. So let's go ahead and give it a shot here. Let's go into insert into students. And then what I want to do is I want to add a student name and student email. The values that I'm going to add here will be Francisco. And for student, let's do student at student.com. I'm just going to add another one here. I'm going to go ahead and do student 2, and I'll have this one be Adam. All right. So if I were to run this inside of PSQL, and I currently have a database named constraints DB, so I can go into PSQL constraints underscore DB. That will take me into my constraints database. I can run \I constraints.sql. So it seems like I have a bit of a syntax error here. I forgot to place my semicolons. Try that again. Okay, so I still have a syntax error. Let me go ahead and find it real quick. Tables not exist. Oh, so I have a syntax error from the very beginning. That's coming from up here. Okay, so now I was able to create the table, so that worked. And now these double quotation marks are throwing an error. There you go. So now we can see that the table was dropped. I was able to create a table, and I added two insert statements. Well, now if I go into select all from students, we'll see that Adam and Francisco were added correctly. They each have their own emails. But now what happens if I try to do this where both of them have the same email, right? Let's try to run that \I. Well, now we get an error. It tells me, hey, there is an error where duplicate key values are violating the unique constraint. And that's happening when I try to add a student email. All right, so when I try to add a student email, it's saying, hey, students at .student.com already exist. And it throws my error. All right. Does anyone have any questions regarding the unique constraint? I like the glasses, Brandon. Looking good. All right. Let's go ahead and move on into our next type of constraint here. The next type of constraint we're going to talk about is going to be our check constraint. I'm actually going to mute this information here just so that we don't get too much noise. So here we have a movie, right? Let's say that we want to make sure that this movie is of a specific age limit um, before we actually go ahead and place the movie into our movie theater stuff, right? So we're running a database for a movie theater. We're checking all of our movies to check what sort of age limit or age constraint they have into them, right? Well, let's take a look at that. We're gonna, again, drop table if exists. This one's going to be a movie. I am then going to create table movie. And this is going to be a movie ID, which will be a serial primary key. We already know what that stands for. We have our movie name, which will again be a varchar of 255. And then finally, we have an age limit, right? And this age limit should be an integer type, but it should also have a check constraint. And this is kind of like an if statement, right? So check if the attempted age limit is greater than or equal to 0. So I'm assuming this is going to be a PG movie. And age limit is less than or equal to 18. Okay, got it. So there's our age limit. We can see that it can be anywhere between 0 and 18. If they put in 18, we know it's going to be a rated R movie. If they put in 13, we know it's going to be some sort of other restriction. I think it's PG-13 in that case, right? So there's our movie. If I were to go ahead and run this script yet again, we can see that, hey, movie table does not exist. So we're going to skip the drop table statement. And then it created a table. Well, let's take a look at our movie. Select all from movie. Forgot the from. There you go. So there we have our movie ID, movie name, our movie age limit. Well, let's try to add an insert statement there. Let's say insert into movie. And what I want to insert is a movie name and an age limit. And I'm going to insert it with the values of, I don't know, let's go ahead and do some JavaScript there, a movie about JavaScript, where the age limit is 13, right? And from there, we could even do it again, but rather than utilizing JavaScript, we could utilize Python and say that the age limit is 21. Well, when I run this code, I expect there to be a constraint error, right? And right now I'm getting some errors because I forgot my semicolons. So I'll try it again. All right, so there we can see that the table was dropped. It was able to create a table. It inserted one movie, which is our JavaScript at the age of 13. But when I try to insert the movie of Python, it says, hey, this doesn't meet our check constraint for the age limit. So you need to make sure that it fixes it. It doesn't necessarily tell you how it violates the check constraint, which is, not the best thing ever, but at least you know that you can go back, check the constraint, and we can see, oh, I try to place in 21 when the age limit is 18. Well, now I know that if I put in 18 and then run this information, well, now I can get both of my insert statements into my database. So then I can say select all from movie, and we can see that we have JavaScript and Python being placed into our database. All right, does anyone have any questions regarding the check constraint? Okay, great. Oh, there we go, Brandon.
You trying to throw some shade right now at JavaScript? It's for
Am
kids.
I? No, absolutely not. All right. Um, so now let's talk a little bit about the check constraint here. The check constraint doesn't necessarily just apply to something as simple as um, checking an age limit and doing it this way. There's a couple of other checks that you can do. All right, so I could say, hey, I want to check if age limit is between, and then I could say 0 and I think 18, and that would also work, right? That's the same application. You can also have a list of ages that you can accept, right? So maybe what we have here is 0, 13, and 18. And then you can say if age limit is in 0, 18, 0, 13, and 18. And that would also work, right? So both of these, there's a couple of different ways to do this to get this Boolean variable to come through. So please don't close yourselves to greater than or equal signs. Go ahead, Eric.
So if you wanted a unique value, would you be able to chain that with the check in there as well?
Yeah, you definitely can. So if you wanted to add a unique value, you could put it with after or before the check. I usually put it before. I try to keep anything that's one word sentence up at the top line. And then if things start getting a little bit too like convoluted, like if you see this one line running for forever, I just enter it and indent it. Right. So it's using the commas at the end of each line as a way of knowing that we're starting a new row. So I don't necessarily have to indent it. I could leave it completely the same, but by indenting it, it tells me, oh, this is all just one row. Does that answer your question, Eric?
Yeah, thanks.
Of course. All right. The other thing that I would like to discuss with everybody is adding a check to something like a string, right? If we had a movie name that we wanted to ensure followed some sort of regex, right? Well, first I would want movie names to be uh unique, right? We wouldn't want them to be repetitive. Usually they're followed by two or some sort of other game title, right? But I could also check that movie name follows a specific regex. And I could say, hey, the regex that I want you to follow is caret, which symbolizes the start of my string, where the first letter will be between A through Z, and the following letters will only be in lowercase, right? And for this one, I believe I need a star somewhere, which means as many instances as possible, right? So there's a continuous amount of instances. And then from there, I just close the string. And the way I close the string is by putting in a $sign, which I cannot find on my keyboard for some reason. Where did you go? There you are. Right. And I'm pretty sure that's correct. It may be a little off on my regex, maybe I'm rusty, but here's the start of our string, symbolized by that caret. The first letter will be A through Z. It will only accept one instance of A through Z because I didn't put a plus sign or a star next to it. And then from there, the following letters will only be lowercase a through Z, and it will accept as many instances of it as possible because of that star to the right of it. So if I were to bring back my insert statements here, so let's say I try to insert into a movie, and what I want to insert is again a movie name and a age limit. I could add my values. Where my values is, let's just go with Python for now. And let's put 13 on there. All right, so it looks like we have a couple of errors. So the drop table did happen. Um, I don't see the create table happening, and that's because of this statement here. It doesn't seem to like it. So let me go ahead and change that to a between statement. I'm pretty sure that should work. So let's go between 0 and, oh, excuse me, 18. All right. Uh, so there we go. We can see that it doesn't exist. So skip the drop table. and then it created the table and inserted 1. So now I can go ahead and say select all from movie. There we can see 1 Python and 13, which is great. But let's try to break our regex, right? Let's see what happens if I try to put all capital letters in. Well, now if I try to put in all capital letters, it tells me, hey, you have an error in your movie because you're violating the movie name check. So again, it's not following my regex, right? I only 1 capital letter is accepted at the beginning, and then after that, it's throwing an error, right? Because I'm trying to have more than 1 instance of a capital letter. So it's not matching my regex. Let me go ahead and put that back to lowercase and try to make some spaces there, which should also throw an error since I'm not accounting for spaces. Okay, so now when I try to run it this way, I still get, hey, this is going to fail because this is violating your movie name check. All right, so now I'm not accounting for spaces, all 1 single word, 1 capital letter, followed by lowercase, and that's the only type of input that it's able to accept. All right, so now I have a unique check for my movie name. I have a regex, making sure that it's being placed in the correct order. And then I have a different check checking my H limit as well. All right, that was quite a bit. Just to do a quick summary here, we created our table of a movie, which has a serial primary key. We then created our movie name, which is a varchar. We decided that that movie name should be unique. And we added a check saying, hey, the movie name needs to follow this regex. This regex stands for 1 capital letter, followed by only lowercase letters. All right, so there you go. And then we have our H limit, which is an integer, and we check that the H limit is greater than 0, but less than 18. All right. Does anyone have any questions over the check constraint or how we could apply it to both strings and integers? Go ahead, Momo.
Yeah, just the command that you put it after you create the table and insert the information. I did that when I was trying to practice in the 32 assignment. But how did you reach this constraint database in the terminal?
How did I reach this constraints database internal? Is
Yeah,
that
I'm
what you're
sorry.
asking?
Yeah, maybe I missed. Yeah, I missed that.
Yeah. So I just put PSQL constraints oh hello underscore DB. But this only happened because I have a constraints underscore DB. If you don't have that database, you need to create it. So you could create that from Linux using create DB and then doing constraints underscore DB. Does that answer your question, Mama?
Yeah, so that's mean from the beginning when I start creating my database, and instead of creating database, I will create something called database constraint database because it will include constraints.
You don't have to create it with something called constraints. I only named it this because that's the topic of the lesson. You could add constraints to any data table or any database that you're currently working in.
So no need to mention or this is not like convention. That this is not mandatory to put constraints in when I name the database, right?
That's correct. Yeah.
Okay,
The only time you need to add the constraints is within here,
okay, yeah, thank you very much.
of course. All right. I see a question from Tim.
Yeah, when you did values Python, you were just using Python as an example, as a name, or
Yeah, I
because
was
you
just
were
doing this as an example.
okay.
Yeah, I could name this whatever I want, right? As long as it follows the regex that I provided. So I could
I
name this.
assumed, yeah, like you could actually make it a movie name as well, right?
Yeah, let's go with
Yeah.
Up. Right? Why not? I like Up. It's a good movie.
Makes me cry.
Every time.
How
Yep.
dare you? Thank you.
Of course. All right. Brandon?
Hey, could you go over the operand tilde on line 20?
Yeah, this right here.
No, the tilde, the squiggle.
Oh, excuse me. Yeah, so this tilde here, it's going to say, hey, what I want you to match is a regex. Without the tilde, if you try to do something like equals or is, it's going to fail. The only way it knows that it's being compared to a regex expression is by that tilde.
So the tilde is specifically for regex.
That's correct. Yes.
Good.
Erica?
So is there any specific reason why you have caps A to Z and then lowercase a to Z right next to it? What if you switched it around?
Yeah, so if I were to switch them around, then what that would, here, let me show you. So if I were to switch them around and try to execute this here, I'm going to get a constraint error. And it's going to say, hey, you're failing. And that's because what I'm asking for now is I'm asking for the movie title to start with a lowercase letter and be followed by a series of uppercase letters. So now if I run it this way, it meets my regex, right? That's not what I want. I want
So,
an uppercase letter to start and then be followed by a series of lowercase.
so if you wanted your limitation to be text only with upper cases and lower cases or numbers or something like that, would that be within the same bracket?
It wouldn't fall within the same brackets. You would have to add those additionally in different parameters. I don't want to get too far into regex just yet. But pretty much the moment you're handling spaces or you're handling anything else that happens, you could either put a space to symbolize that, or you could actually address it with a pipe and a underscore to let the program know, like, hey, we're also accepting spaces.
Okay, thank you.
Of course. All right. Let's move on into our not null constraint now. We've seen a couple of informations here. But let's go over this scenario, right? So in a database managing inventory, the quantity column in the products table may have a not null constraint to ensure that each product entry has a defined quantity. Okay, well, that's great. Let's go ahead and start going into that, right? We're going to go ahead and create a table for products. So first I'm going to say drop table if exists. The table is going to be named product. I'm going to then create table product. It will have a product ID, which will be again a serial primary key. It will have a product name. And for product names, again, I think we should make this a varchar, which will be, I don't know, maybe let's go with 100. Let's make it unique. And ideally, we would want to add some sort of check constraint. But just for time's sake, we're going to move on to the next one, where we have quantity, right? And for quantity, well, this should be an integer type. This should not have that there. I apologize. It should also be, it should not be unique, but we talked about being able to pass in null values, right? We haven't necessarily discussed when something should be null or when it shouldn't. But automatically, PostgreSQL, unless you specifically tell it that, hey, this is not a nullable field, it's going to make it nullable. So you want to ensure that something isn't nullable. For example, our product name. We want to ensure that our product name is always existing in our database. We also want to make sure that our quantity is always existing in our database and that it's always greater than 0. So all we're going to do is we're going to explicitly tell, hey, this is a not nullable field. And I want you to check that quantity is greater than or equal to 0. All right, so there you go. There's my check constraint. And for the following of product, I also want to make sure that it's not nullable. Right, so now when somebody tries to insert something into this table, if they do not provide a product name, it will throw an error. So let's try to take a look at that. Let's go ahead and do insert into product. Again, we want our product name and we want our quantity field. And let's actually do it without not null first so that we can see the issue here. And what we're going to add is the values. And let me actually just specify that all I'm adding here is quantity. Right, so let's say that the quantity that I want to add is, let's go with 20. All right. Well, now let's go ahead and run this script and see what we have inside of our table. So I'm going to go ahead and say select all from product. All right, well, there we can see that a new product was created, but this product was created with a product ID and no name. There was no name representing this product, and I never got an error because I never specified, hey, this is a not nullable field. So I'm going to go ahead and add that not null constraint. And now when I try to execute this script again, I get an error. It tells me, hey, you're trying to add a product, but the product name is a not null constraint. You need to make sure that what you're inputting into the database has something other than null. Well, that's what forces me to go ahead and add product name. And what I want to go ahead and put here is, I don't know, let's go ahead and go with keyboard. Why not? All right, and we have 20 of them. Well, now when I run it, it's able to work correctly. And if I select all from product, we can see that we have our product ID, our product name, and our quantity all being placed together. And now anyone else who tries to interact with our database, they're not able to interact or place something, insert something into this table that does not provide both the product name and the quantity. Does anyone have any questions regarding not null? All right, let's hear it, Tim.
If it doesn't have a product ID, for example, and you only have a product name and quantity, is there a way to put that in the system still?
Sorry, could you say your question one more time?
So if you don't have product ID number, but you have like a product name and quantity, could you use that, like, for example, in retail, you would use like a SKU number or something, an SQU number. And if you don't have that, but you know what the name of the thing is, and you have a quantity, could you do something like that? Or does it always have to be product ID?
Yeah, that's a
That's
great
just
question. Yeah,
self-generated.
no, that's a great question. So most of those numbers that you're referencing to, I'm sure we've all seen it before where, each individual product has their own product number inside of a store or something like a UUID. There's different ways to have PostgreSQL work with that information and treat that as the primary key. It just wouldn't do most of the serialization for you. You'll have to specify that it's unique and that it is to be utilized as a primary key. And you also have to make sure that you include a pretty strict check constraint to check that the specific number values or letter values are being placed in the correct order. Does that answer your question, Tim?
Yeah, thank you so much.
Of course. All right. Awesome. Well, we've talked a lot about all of these constraints, but now let's go ahead and put them into practice. All right. Let me go ahead and grab some of our data from yesterday. I'm going to go ahead and do a copy command here from yesterday's data schema. I'm going to bring it in here. So there you go. We have our data now. And now I'm going to go ahead and CP. I think I named it store SQL. Nope. Let's see. There you go. Game store SQL. And I'm going to put it in here as store to.sql. All right, so there you go. We have our store. This is where we finished up yesterday after yesterday's demonstration. And we talked a little bit about constraints so far. So now let's go into applying these constraints, right? So currently we have our game ID, which is a serial primary key. Okay, great. What about our game title? What kind of checks do we want to add into our game title? And takers? All right, let's hear it, Daniel.
For the game title, we can just have just like one capital letter.
Okay, so you're saying that we want to add a regex check, all right? What other
Yeah.
kind of check do you want to add to this game title?
That
Okay, if there's anything else.
not what I can think of right now.
Okay, awesome. Erica?
So you want to have a check of the line of text that you wrote so that it like, but I wouldn't say that it starts with it needs to have letters and numbers.
Yeah, let's
only.
take a look here. If I look at my game, it doesn't just accept, yeah, it accepts letters, numbers, and it
That's
also
Oh, and spaces, sorry.
yeah, we have spaces and we have
Yeah.
special characters as well.
Oh, yeah. Well, the specific special characters, I would say, so that it doesn't run wild.
Yeah. Awesome. Okay, so we're still talking about that regex check constraint, which we'll go into applying it here shortly. But do we want people to be able to play something through the database without a game title?
No, it needs to be not null.
Okay, awesome. So we want to make sure that this is not null.
Mhm.
All right. And then for game titles, do those ever happen repetitively, or do we want it to be repetitive?
Oh, I guess it can be unique, yes.
Awesome. And then we would add a unique. Okay.
Yeah.
Great.
And then you have to have the check for it so that you don't write whatever nonsense in it.
Right. Okay. What about our quantity? What kind of checks do we want for quantity for this game? Let's hear it, Chris. What do you got?
For quantity, yeah, check if it's a number.
Okay, so we're doing that with the integer field there. What else?
Okay. Mm. Check it. Well, what's the format for quantity for the game?
Are
Is
you
it a
talking about, you want to
two-digit?
say the data?
Yeah, is it a yeah, so make sure it's not a decimal or well, it's in, so I'm not for sure.
Okay, awesome. Let's go ahead
The-
and
Oh,
oh,
sorry.
Momo, go ahead.
Yeah, check the availability. So it should be greater than, that's what you mean? Check because it's all available, right? The game. So, oh, that's the title.
No, we're talking about quantity here.
Quantity,
And
yeah. So it should be more than 0, right?
okay,
Check.
great. Yeah, so we want to have a check that it's more than 0. Otherwise, why would we have the entry, right?
Yeah.
Erica?
We may also, if there's like a max, we also might want to check that it doesn't have more than X amount of copies so that we don't overstock.
Okay, and let's say less than 100, right? There you go. because we don't want to overstock in one specific game. All right, great. Well, what about price? How do we handle price? Well, let's say
Yeah.
that our store is committed to low prices, and because of that, we should make sure that our cost is always above $10, but always less than $60. How could we do that? Go ahead, Brandon.
Between statement.
Yeah, so we check between 10 and 60. Whoa, there you go.
That's not realistic though.
Yeah, no,
that
that.
is. I buy $10 games all the time.
Oh, there you go. You gotta tell me
Collector's
where you get those
editions are
games.
$200, okay?
Okay. Okay.
All right, so let's get into this. What is this gonna look like, right? So starting off with our varchar for our character or for our game title, we said that we wanted it to be a unique. We also stated it that we wanted it to be not null. And we have a check that we want to have to apply. And this check is going to take in the game title and apply a regex into it, all right? Now, this regex is going to be a little complicated. So we want to ensure that our title starts with either an uppercase letter, a lowercase letter, or that it accepts 0 through 9. This should also look for spaces of a special character that we're defining. This is the special character we're looking for. We're also accepting underscores or hyphens. There we're specifying a space, and we want to escape that space because that's what we started our string with, and that's what we're closing it with. So we want to make sure we're escaping so that the regex can know this is, oh, this is just part of the regex. It's not closing anything. From there, we want to close it and say, hey, I expect one or more instances of this regex. And there you go. All right, there's our really complicated regex. It's accepting any one of these letters. Oh, hello. Almost messed that up. It's accepting spaces. It's also expecting hyphens or underscores with a colon. It can accept quotation marks. This is just us escaping the quotation marks. And then it wants one or more instances of that regex pattern. All right. Erica and Brandon, I think both of you had your hands up, but Erica, you have yours up still. So what's up?
I assume usernames would follow something very specific, something very similar, right?
Depending on what you want your usernames to have. Usually when we're talking about users and how you're going to be managing that for your applications, you'll be handling that within Django. So you can make that unique. What a lot of people or a lot of applications actually do is they utilize their email as the username. So then that way it's already enforced. Hey, this has to be a valid email and this must be a unique pattern. So that's usually what gets applied in that. Does that answer your question, Erica? Awesome. Brandon?
Yeah, I put my hand down.
Okay.
Try not to get into regex.
Okay, awesome. Momo?
Yeah, what the meaning of the condition Z, the Z followed by 0?
So this is accepting anything that's capital letters, alphabetical
Yeah,
letters between A through Z.
Yeah,
This
I know,
is-
just, yeah, the one in the middle, yeah, 0, the Z0.
Yeah, you gotta wait for me to explain it. That way you
Oh,
could
sorry.
understand it.
Okay.
Then we see the lowercase letters of A through Z, which is the pattern. And this 0 through 9, it's its own pattern.
Okay,
It's
I'm
not
sorry.
combining
Yeah,
those two.
yeah, okay, I'm sorry. Thank you.
Yeah, no problem at all. All right. So there you go. We have our game title check. We made sure that it was not nullable. We ensured that it was unique. And we have a regex check for it. Great. Well, now let's move on into our integer portion, right? Well, for not quantity, we have, for our quantity, we did expect to have a check. This check ensures that quantity is between 0 and 100. But I have a little bit of another question, right? So we have this here. Remember that something being not nullable has to be explicitly told, right? So yes, we have a check ensuring that the quantity is between 0 and 100, but we're also accepting nullable statements here. So somebody could write a new game without providing a quantity. That's not what we want. So we want to make sure that we add a not null constraint. Brandon?
Could we not use this opportunity to set a default value? So like, let's say we want to keep track of a game that is not quite released yet. But we do want it in the database, so we could set a default value to 0 instead of not null. That way, it'll still accept the insertion and also give us actionable data.
Yeah, let's check that out. Actually, haven't experimented much with default values here on PostgreSQL. Definition, default values are listed after the column data type. For example, create table. Got it. So we could add a default value if we wanted that, right? We could go ahead and it says to put it at the end. So I'm gonna go with default of, and let's say 1. Right? So we could also put that in there to ensure that we're always grabbing a value in. Is that what you were referencing to there, Brandon?
Yeah, absolutely. I think that would be better than adding not null. So setting the default value to 0, I think, would be better. Because we're not always going to have a game.
Got it. Well, I would say that you would always want at least one copy, whether it's for display or something like that, until we get restocked. Maybe you're right. Maybe we're not always going to have the game, right? So we could definitely put this at 0. As far as the not null statement, I strongly recommend that even though you provide a default value, you put the not null statement. It could be a little bit of overkill, but it could prevent some unexpected behavior later on in your programs as your database grows.
So is that also to prevent the user from injecting null? Like, if you don't explicitly say not null, could someone try to pass null in as a value?
Right, that's correct.
Okay.
So somebody
Okay.
could still pass in null as a value. All right. And then finally, let's go ahead and move on into our prices. So our prices, again, we don't want it to be null. So I'm going to go ahead and add not null. And I'm going to add my check statement here where I'm checking that my price is between 10 and 60. Right. And then just like Brandon just added into our project here, we could also add a default value where the default value is 1001. All right, because we want it to be between 10 and 60. All right. So there you go. There's my game now. Turned into a very simple game. And now we've added some check constraints to ensure that our game is accepting only clean data every time my CSV gets loaded. I see we have a question. Go ahead, Eric.
Yeah, just the last example you put in there, the 1001 to be default to be between 10 and 60, raises the question, is between inclusive at the start and end? Because you just have default 0 on the first example.
That's a good question. Yeah, let's check that out. Let's see. Between in PostgreSQL, is it inclusive? There you go. So it is inclusive, meaning that the beginning and ending values are inclusive.
Okay, cool. Thanks.
Of course. All right. So there we have it. Now let's put it to the test. Let's see if this will actually work. I'm going to go ahead and go into my game store. All right, so I'm within my game store, and now I'm going to go ahead and run this script here. Ooh, and I think my game store is actually dirty from something that I was doing. So let me go ahead and fix it. I'm gonna drop my database and create the database game store. All right, now I can go ahead and enter game store to ensure it's empty. I can run \i store underscore to.sql. All right, and we can see that the table, it tells me, hey, the table does not exist. We're going to skip the drop table statement. It created the table, copied 10 records from my CSV file, and then it did that set value to fix my serial primary key. So let's start with the serial primary key here. I'm going to go ahead and select all from game ID. There we can see that we have 10 with 1. And I can run select all from game and see that all of my games were inputted correctly with matching the regex that I've provided and all of the constraints that I've provided for my data. All right. And that is it as far as constraints before we go into some foreign key relationships. Does anyone have any questions regarding constraints? All right. Well, I know there's a lot of talking and just coding, so I hope people aren't getting bored on me. This is something really useful, and you're going to continue to use this throughout, all of your Django and any sort of framework that you utilize will have something called validators that will interact with your models, which is what goes into your database. And the validators are essentially just picking up what your constraints are doing inside of PostgreSQL. All right, if there aren't any questions, I'm going to go ahead and pause the recording. All right, welcome everyone. Oh, go ahead, Mama.
Yeah, I just have a question because last night when I tried to practice, I was working only on the terminal. How did you make this SQL file on the VS Code?
Oh, this one right here, I used the command touch, and then I place relationships.sql. Oh,
So you're just creating file for SQL on the command. Okay.
yeah, that's all I
Okay.
did.
Okay, thank you. Yeah.
Of course. All right, so now we've talked about constraints a little bit, but we haven't really talked about relationships much. Yesterday, we went over an example of, or a couple of separate examples of relationships. And if I pull them up here, we can take a look at them, all right? So there we can see we have our one-to-one relationship, we have our many-to-one relationship, and our many-to-many relationship. And we also went along into mapping these inside of DrawSQL. Let me go ahead and make sure that we are on the correct one. We are not. Yeah, we also went ahead and drew these out inside of our DrawSQL, where we talked about how they would connect to one another, having a one-to-one relationship, but we haven't gone about how does this look like in some SQL code. So today, that's what we're going to be focusing on. How do we turn these relationships into SQL code? And the first thing that we're going to start off with is going to be our employee table. All right. So I'm going to have an employee, and each employee is going to have a social security. So I'm going to drop table if exists. that table will be employee. I will then create a table for employee. And I'm going to actually pluralize it this go around. I'm going to have my employee ID be a serial primary key. This shouldn't be any surprise to anyone. And then we should have our employee name, which I'll place as a varchar here. I'll make it, let's say 100, just for simplicity's sake. I want to make sure that this is not a nullable field. And there you go. And then I want to make sure that I create a table as well for my social security. So I want to drop table if exists. And what I want to drop there is the social security table. I'm going to create table. And just to keep a good convention here, I'm going to do social securities. And this table is just going to have a SSN number, which will be a varchar of 11. It should be unique. And it should also be a not nullable field. So there you go. I have my two tables. Currently, there's no relationship between one another, right? I just have a table that can create an employee, and I have one that can create a social security. Well, this is all great, but what does that look like inside our code here? Let me go ahead and connect to our relationships DB here. Okay, and then I'm going to run \i relationships.sql. And I can't spell. All right. So there we see I have a couple of syntax issues. I forgot my semicolons there. So I'm going to go ahead and run this again. All right, so it tells me, hey, this table employees doesn't exist, so we're going to skip it. And then it created the table. It then did drop the table for social securities and then created the table for social securities. So let's look at our relationships here. So there we have our employees. We have our employee IDs. And this is the sequential letter. And then we have our social securities. In this case, the social security doesn't have a serial primary key. But I'm going to go ahead and add one in there. I'm going to go ahead and do serial ID. I'm going to go ahead and do a serial primary key. All right. I'm going to execute my file one more time. And now when I look at my relationships, I see that I have two sequential tables keeping track of my entries. Great. Well, if I go to select all from employees, and I run this, I can see that I have an employee ID and an employee name. And if I do the same thing, but instead I go into social securities, I see that I have a social security ID and an SSN. But how do I connect these two together? Right? Well, let's say that I wanted to have a connection where the employee ID matches the employee. Well, I can just say, hey, this should be an employee ID, and this is going to be an integer, right? Well, okay, that's great. I can also run this information. Oh, excuse me. Right, that still works. It's able to create my table. And if I run select all from social securities, we'll now see that there's a field for employee IDs. But there's a bit of a problem here, right? If I were to create a series of employees and a series of social securities, there's nothing really enforcing the connection between employees and social securities, right? I could put in any integer for employee ID, even if it doesn't match the employee ID up above yet. So what I actually need to do in order to fix this one-to-one relationship is I need to make sure I specify a foreign key. All right. So how do I do that? Well, I can say, hey, this is going to be a foreign key relationship. That foreign key relationship will happen within employee ID. And it's going to have a reference to the employees table in the field of employee ID. Now, when I execute this file, oh, looks like I have an issue here. Let me go ahead and check what's going on there. Oh, I forgot a comma. All right, so there you go. All right, everything was created. If I look at Social Securities, nothing really changed. The only difference is that now, when I try to create a Social Security, when I input an integer here, it's going to find a match within the employee ID. So let's take a look at that so far. I'm going to go ahead and say insert into employees. What I want to insert will be an employee name. And it will have the values of Francisco. Why not? All right, so there you go. There's my one employee being inputted into my database. Well, now let's say I try to insert into Social Securities. And the only thing that we really need to place here is going to be the employee ID and the Social Security. Well, let's take a look at that. I'm going to add the values of 1 because I will have one entry right up here. And for Social Security, I specified that to be a varchar of 11. So I'm going to do. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm assuming that I added hyphens when I first created this. So there you go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there you go. There's my 11 for the Social Security number. I'm able to create this and do these insertions. So now let's go ahead and run this file. All right. So here I'm running into a bit of an issue. All right. And this is happening because of my foreign key relationship. And this is good that we're running into it now. If we take a look here, it's telling me, hey, you cannot drop the table employees because other objects depend on it. Well, currently I have this table of Social Securities that's depending on employees. So in order to drop the Social Security table, in order to drop the employees table, I have to drop the Social Security table first. So I'm just simply going to take this up here, and then I'm going to execute my code. All right, so there you can see Social Securities was dropped first because its dependency on employees is no longer there, or the dependency of employees on Social Security is no longer there. It was able to drop the table for employees, and it was able to conduct 2 insertions. Well, now let's go ahead and select all from employees. We can see that I have my employee ID and employee name there for Francisco. And if I were to select all from Social Securities, well, we can see that I have one Social Security that's been placed in. The employee ID is 1, so it matches to Francisco. So currently, Francisco's Social Security would be 666, the whole series of 6 for Social Security number, right? And this is how we connected these two tables. Now, oh, go ahead, Chris.
I'm just a little confused. Why drop a Social Securities? Why drop it and then it's still in your code? So
You're saying why drop Social Securities first?
yes.
Yeah, so if you try to drop employees before dropping Social Securities, this foreign key reference will throw an error because it's going to say, well, employees is being dropped, but currently I have a connection to employees.
Okay. and
So
then-
if I try to drop employees, how am I going to handle this? So it throws an error. So I have to drop the social securities table first so that there's no reference to it, and then I could drop employees. Go ahead,
Gotcha.
Chris.
Yeah, I'm thinking I'm just confused. Why are you dropping tables regardless?
Oh,
And-
currently I'm just dropping tables so I could rerun this script over and over again.
Okay. Okay. I'm gonna just let you continue so I can understand it better.
Okay. Awesome. Brandon? If you're speaking, you're muted.
I was just gonna add my 2
Oh.
cents. Sorry, never mind.
Oh, okay. Got it. Momo?
Yeah, I just want to ask a question. I don't know if it will make sense or not. Why, from the beginning, we made two tables, okay, sharing one property like this, the social, the employee ID. Why we didn't make it just one table, like the employee, and we add to the employee the social security?
Yeah, that's a great question, right? Why not make it just one table?
Yeah.
So this has to do with kind of it's one of the topics of normalization, right? You don't necessarily want everything to be within one table, and different things that should be handled separately should be its own separate table, kind of like an OP, right? In OP, we practice composition, where we don't have is a part of this other class. We have has a part of this other class, right? Think about updating something that has to do with Social Security, right? What if this person wants to get their Social Security record updated? If we were to put it all within employees, well, then this entire record would have to get updated. And any connection in any other table that we have to employees or any logic that we have to employees may have to change as well, depending if we have any sort of ternary statement working off that Social Security, right? Well, when you have it isolated to its own table, you can update that one record, still keep the same connection, but now you're ensuring that behavior is being isolated to individual tables. Does that make sense?
Yeah, so that's like to secure the data or to save the data from any damage, or that's what you mean?
You could look at it from that way, right? It's to protect data and to make sure that data
Yeah,
is
protect data.
consistent as well. Yeah,
Okay, yeah, thank you.
of course. Brandon?
And what we're doing here is the topic of normalization that you explained in the first day.
Right. There's a little bit of normalization going on here. Yes.
And specifically, that's happening on line 14, where we're referencing a different table. That way, when that table changes, this foreign key is also updated.
So normalization is more of a concept rather than a strict code. So I wouldn't just say that line 14 is what does it. It's more the fact that we have two separate tables isolating behavior. That's what's enforcing normalization.
Okay. So the structure enforces the normalization, and the syntax that allows that type of functionality is using foreign keys and references.
Correct. Yes.
Okay.
All right, Erica.
I just Googled it and it states that you can also add cascade to the end of the drop table if it exists to erase all dependency automatically, like erase all dependent objects.
Yeah, you definitely can. And I'm glad you looked that up. I'll do a quick demonstration of that here shortly. All right. So now we have this unique key and we have a reference to it. But this right here, what we've created so far in this table, is not necessarily enforcing a one-to-one relationship just yet, right? If I were to create a second entry of a Social Security, and instead of 666, I pass in 777, and then I run this information, we can see that all three insertions happen correctly. There's my employees table, and here's my Social Security table. Well, now there's a problem because I have two separate Social Securities being referenced to one employee. Well, now we have a many-to-one relationship, so this isn't working. That's not what I wanted, right? Instead, what I need to do is I just need to add a separate argument saying, hey, this has to be unique, right? And just by saying this has to be unique, well, when I try to add that second connection to it, it's going to see the repetitive IDs of 1 and throw an error. So let's go ahead and try to run that \i. So there you go. We see the insertion of 0, 1 happening here. We see the second insertion of the first social security. And now when we go into that third insertion, it says, hey, you have a duplicate key constraint, which violates the unique constraint. And you can see that it's happening at the employee ID of 1. So that's happening from here. And if I run my select all from employees, Francisco's still in there. If I run it from social securities, only 1 entry was placed into the database, enforcing that one-to-one relationship. Right? So make sure that whenever you're creating a one-to-one relationship, you're adding that unique as well. Not only just to the foreign key reference, but you need that unique constraint to that employee ID. Okay, any questions over one-to-one relationships? All right, if there aren't any questions, let's talk about something called cascade here. Right, so I believe, oh, what did I just do? There we go. Correct me if I'm wrong, Erica, but the cascade would go here, right?
But I don't know where you are.
Can you not see my VS
Oh,
code?
yes, I sorry, it's the laptop that I can see, yes. Oh, so according to, I just sent it on links. You can add the cascade drop tables if exist, cascade or restricts right next to it, but there's also another, there's also a way to put it right there too. I'll send that link too in a second, because I got both links. They're linked in the
I don't
link chat.
see any links populating here. I'm looking
It's
at X-ray questions and
Oh,
the
resource
chat.
links, no conversation, sorry. I just dropped it where the resource links are.
Okay, got it. I don't have access to that, so maybe we could go over Cascade at a separate time. All right, everyone. So now that we've talked a bit about our one-to-one relationships, let's go ahead and move into our many-to-one relationships, which is going to look pretty familiar. So for a many-to-one relationship, the one thing that we've talked about was in reference to what's in reference to, oh, excuse me, in reference to people flying on a plane and luggage that they are carrying. Well, let's try to go over that. Right? If I have many people trying to board a plane and they're all carrying luggage, and actually this isn't an example that we have in our code in today's curriculum, so I'm going to go back to our code in today's curriculum where we're going to have universities and students, right? So we have many students attending one university. So I'm going to go ahead and do drop table if exist. It's going to be universities. And then I'm going to create the table universities. What we have here is university ID, which will be a serial primary key. And then we have our university name, which will just be a varchar. Again, let's do 100, and let's set it to not null. So there's our first create statement. And then let's go ahead and make our table for students. Right? So I'm going to go ahead and drop table if exist. we're gonna add students. Then I'm gonna go ahead and do create table students. And in this create table for students, I need a student ID, which again will be a serial primary key. And I need a student name, which will just be a varchar of, let's say, 10, and let's do not nullable. And then finally, let's go ahead and add that university ID, which will be an integer type, and we will ensure that it's not nullable by adding a reference here, right? So there you go. Currently, we have our university and we have our students. We're trying to mimic this situation here, right? Where we have a university and here we have a series of students. Well, we've already did this when we created our one-to-one relationship, right? It's going to look very similar as far as syntax. I'm actually going to create. Oh, and I see we have a question. Give me a second for creating this connection, then I'll go open for questions. So we're going to create our foreign key relationship here of university ID, where it's going to have a reference to the table of universities at the field university ID. Right. All right. Let's open up for questions. Go ahead, Momo.
Yeah, I'm just wondering, you said we have, the foreign key should be unique, right? So why you didn't make it unique in this case?
Yeah, so that's a great question.
And the create table university, the
Yeah.
university ID.
The university ID is unique
Yeah.
because we have a serial primary key. So by putting it in serial primary key, it's always going to be unique.
So, okay, I got it. Thank you.
Of course. All right. So now we'll see that when we created the social security table, we added this unique constraint to the employee ID. And that's what enforced this one-to-one relationship, right? I couldn't have a duplicate of an instance of a social security because it wasn't a unique constraint. It could only be attached to one person. And one person can only hold one instance of a social security. Well, here in universities, we're just not going to add that unique constraint. And by not adding that unique constraint, well, then we're making it possible for multiple students to attend this university. So let's take a look at it. Let's say I'm going to insert into universities. And what I want to insert is a university name with the values of, and let's go with code Platoon. Why not? And then finally, I could insert into students. And what I want to insert here is going to be both a student name and a university ID with the values of the first one being, let's say, I don't know, let's go through here. Let's just put Momo and let's do 1. And instead of Momo, let's put Dustin. And finally, one last one, which in this case, let's put Polly. All the in-person students got to represent. All right, so now let's run our \i for relationships. All right, so there we can see, hey, the table students does not exist. And neither does university. So it skipped the drop table and then created the table. And then it made all of our insert statements. So let's take a look here. let's select all from universities. We see that we have one university named Code Platoon. And now let's select all from students. Well, now we can see we have 3 separate students, Momo, Dustin, and Polly, and all of them are attending the university, matching the ID of 1 for Code Platoon, creating a many students to one university, a many to one relationship. All right, does anyone have any questions about this? All right, let's talk a little bit about Cascade real quick. Oh, Momo, go ahead. Oh, no question. I heard a hand pop, so somebody must have had a question. There you go, Chris.
Okay, in the diagram, you have universities, but you have, so was student, okay, you have student there. So all these are just students. Okay, meaning to one relationship. Okay. I was confused with the luggage. I didn't see student at top. Thank you.
Yeah, I apologize. Yesterday we did different set of examples, that's why. All right. So now let's talk a little bit about Cascade, all right? If I try to run this code again, I'm gonna run into that same issue that I had earlier. It's gonna tell me, hey, you can't drop this table. It's gonna say you can't drop this table because we're dependent on some objects. If you want to drop this table, it tells me utilize Cascade. Well, what is Cascade? All right. And it's a little bit easier to visualize once you have a many to one relationship. Well, all Cascade does, and I believe we can just place this up here. All Cascade does, so here we go. I run it. So notice drop cascades to constraint student university D key on table students. So all the cascade is doing is it's saying if there's anybody referencing this specific university or any data inside of this university, remove that relationship as well. All right, so there we go. It's going to tell me notice drop cascade to constraint students, foreign key on table students. So it dropped the constraint of the foreign key relationship. It didn't drop the table itself. It just dropped the relationship. All right. The drop table then happens. I then create my table of students, or excuse me, of universities. Then I drop the table of universities, recreate the table of universities, and run all of my statements. So I can still have my code pretty well organized. All I'm doing is adding the cascade. Cascade is not dropping the data itself. It's only dropping the foreign key constraint. All right. Any questions regarding Cascade? Okay. If there aren't any questions regarding Cascade, the final topic that we're going to be covering is our many-to-many relationships. And let me actually just deduct this to 2 to try to make it a little bit simpler. I'm going to get rid of all of these errors. And in today's example, what we're going to be covering is going to be students and actually let's just drop it to 1 for now. And our course. All right, so every student can take a course. And we're going to be talking about how we create this many-to-many relationship, right? And this many-to-many relationship, what it basically stands for is that many students can attend many courses at one time, and many courses can have many students. Now, we look back at our TL draw schema, or sorry, our draw SQL schema here. When we had our many-to-many relationship, we actually created a connecting table. This connecting table utilized a different foreign key relationship of many to one. So let's get that going here. inside of our own project, right? Let me move this a little closer so that we could see it on the screen. Oh, hello. Wow, looks like I copied a lot of circles. All right, so let's start off with making these two tables. I'm gonna go ahead and comment this information out here. Oh, well, we already have students. Yeah, it should be fine. I'll just drop the table if it exists. There we go. All right, so let's start off with our new table. All right, we have our students and we have our courses, and it really doesn't matter in which order we create them because the connection is going to happen in a third party, right? So I'm going to drop table if exists students, and then I'm going to go ahead and create table of students. Now, this student table is not going to be anything special again. We're just going to have my student ID, which is going to be a serial primary key. And then I'm going to have a student name, which will be a varchar of 10. And I'm going to go ahead and say that it will not be null. All right. So there's my student table. Well, now I need to add a drop table if exists. And I'm going to go ahead and add that to courses. I'm going to go ahead and create a table named courses. Well, now this table courses has a course ID, which will be a serial primary key, and it has a course name. Which will be a varchar. Again, let's make it 10, and let's set it to not null. Well, there's both of our create table statements. We have a course and we have a student. As of right now, there's no relationship between them, right? And how could we handle this relationship? Well, again, we can't have a reference to one another because that would break our code and it wouldn't necessarily make any sense. There wouldn't be a way to cascade that information or to handle these references if I were to have a connection between students and courses and then a opposing connection between courses and students, right? So instead, I need a way to handle these record entries separately, right? So now, how could I do that? Well, let's try to do the first example that I just talked about so that we can see the problem before we actually start breaking down the third table. Let's say that I want to have a course ID here. I make this an integer, and then I establish, hey, this is going to be a foreign key relationship, and this foreign key relationship will be to courses. And just so you know, this foreign key relationship will then have a references to courses course ID, right? And down here, let's try to say that I have a foreign key relationship. Oh, excuse me. To students. And this foreign key relationship has a references to students, student ID. All right. So just looking at this data table here, all right, or imagining this data table here, what are the issues that we can encounter? If I wanted to create multiple students or a student that attended multiple courses, how could I do that? Because each entry of a student is already unique, right? Each record of a student should only be one. But currently, if I wanted a student to attend multiple courses, I would have to create that same student multiple times. with a separate course ID. And the same thing with courses, right? If every single time a course had a different student, but I would have to duplicate the entire course over and over again with just separate student IDs. And that's not what I want, right? So this isn't working. It's not what we desired. We're going to go ahead and remove those foreign key relationships because that's not what we want. So currently I have these two tables. Let's go ahead and run our \i here. And let's add that cascade keyword into both of these. Okay, so there we go. Everything worked. I can run my select statement that receive the student ID and student name. And I can select all from courses. And there we can see my course ID and course name. Well, now I need a way for many students to be connected to many courses and for many courses to be connected to many students. Well, here's where I would create a separate table. So I'm going to say drop table if exists, and I'm going to name this one course students. And this one doesn't need the cascade keyword. I am going to then write my create table statement. This one will be named course students. And all it's going to take in is it's going to have a, let's say course students ID, because we do still need a way to reference this. This will be a serial primary key. And now all we need is a student ID, which will be an integer. And we need a course ID, which will also be an integer. Now, both of these are going to be used as a many-to-one relationship. All right, so let's go ahead and add this separate table here. Gonna make it an octagon. And I'm gonna call this course students. And rather than having a connection, oh, that's too much. Rather than having a connection between students directly to courses, what we created here is a connection where courses or course students can have a many-to-one relationship in both directions to students and courses. And that's what allows this many-to-many relationship to work. All right, so if I were to expand this a little bit, well, what this may look like is something like this, where I may have another student, all right? I have a separate course down here, but the student right up top, rather than just only going to that course, well, he's also going to course B down below. And this student down below, he could also be going to course A right above. And that's what's making our many-to-many relationship possible there. Go ahead, Erica.
So does that need serial primary key, or can you make the other two ints that are your reference the primary keys, both of them?
Yeah, you could definitely do that where you can make the other two your primary keys. So you could do this like this. You can group them and say, hey, the primary key here would look like student ID and course ID, right? And you could establish that to be your primary key. Now, the issue with doing this, not necessarily an issue, but the reason why I'm teaching it the other way is because once we start working with other programs or frameworks, you'll realize that every record, regardless whether it's a joining table or not, will have its own serial primary key. So I just want to make sure that we're all seeing that consistency. And rather than seeing the pure PostgreSQL way of managing this information, you're seeing what it would look like when you have a framework assisting you with this interaction. Does that answer your question, Erica?
Yeah, thank you.
Of course. All right. So now let's go into making this reference, right? Like we said, we want a many-to-one relationship. So all we would do is add a foreign key relationship, and we would do it on student ID, where it's referencing the student's table at student ID field. And then we would want one last foreign key relationship. For the field of course ID, where it's going to be referencing the course's course ID. And this would then create our many-to-many relationship, right? I could have multiple instances of a student and multiple instances of a course, but what makes this many-to-many relationship is these records in the middle of course students, where every time they're being created, every time they're being created, they could attach to multiple courses because of their many-to-one relationship. So now let's take a look here. All right, let's say I want to run this relationship. There you go, everything works well. It was able to drop a table and create it. They went all the way to course students, but with course students, it didn't exist, so it skipped the dropping table statement. All right, this is great. We haven't seen any data in practice though, so let's take a look at that. Let's go ahead and insert into students. And what I want to insert there is going to be the student name. And I'm going to insert with the values of Francisco. Let's do Adam. Let's do Raphael. And finally, let's do Zainab. All right, so there's our 4 students. They're all being placed into our database. Well, now let's go ahead and insert into our courses or course name 2 subjects. Let's do a values of Python. And then finally, let's do our values of JavaScript. Let's run all this insert table so you can see everything was dropped correctly and created correctly. Well, let's select all from students. There we can see our students, 1, 2, 3, 4 of Francisco. And let's actually copy and paste this. Let's see if I can put this somewhere over here. All right, so there's our student circle there. All right, we can see all of our students being made, just like we saw above. And now let's go ahead and select all from courses. There you go. We have all of our courses as well. So now let's go ahead and grab our triangle. Let's copy this information here. And let's drop it into our triangle. Ooh, that's not looking too well. There you go. All right, so there you go. We have our courses and we have our students, but as of right now, none of our students are signed up for any courses. Well, we have all of our IDs here, and we could start creating some records, right? Some records for core students. And as you can see here, those records on core students, all we need is the course ID along with the student ID. So let's start doing that. I'm going to go ahead and insert into course students. And the values I'm going to insert is going to be student ID and course ID with the following values. Well, let's say I want Francisco to take both Python and JavaScript. So I would say Francisco's taking Python. So the number 1, the first one matches to the student, which is Francisco. And the second number 1 matches to the course, which is Python. And now I can say, well, all right, now that I have Francisco attending Python, we also want him to attend JavaScript. So again, the number 1 relates to Francisco, and the number 2 now relates to JavaScript. All right. Well, now let's have Adam also attend to both of these, right? I'm gonna copy both of these insert statements, bring them down below. And all I'm going to do is switch that first number 1 to a number 2, which is referencing to Adam. So now the student Adam is attending both Python and JavaScript. Let's run this real quick. All my insertions happen correctly. And if I now run my select statement from course students, well, now we can see those entries. All right. So there's those entries happening here. And if I were to move this to the side a bit and bring up my octagon, or I don't even know if that's an octagon, whatever this shape is, and I place my information, well, now we can see how these tables are being related, right? We can see how we have our student ID. There it's matching 1 to Francisco. So let's do Francisco in the color red. Oh, probably not the best way to do that. Let me go ahead and choose the pencil. Please don't make fun of my lines. So here we can see Francisco going to number 1. Francisco going to number 1. And Francisco is currently attending the course for Python and is also attending the course for JavaScript. Well, now we can also see Adam is attending here and attending here. And Adam is also attending course 1 and he's also attending course 2. So there's our many-to-many relationship being enforced. And I saw a hand pop up earlier. I apologize for not getting to it. I think that was Erica. Erica, was your question answered, or do you still have a question?
No, it was just if so this is, I see the insert into with the back end. I'm assuming for this you build a front end that would allow you to pull when you insert the data into it. It wouldn't necessarily be 1-1. It would actually call for the name and the name of the class, I would assume.
That's correct. Yes, that is a very good assumption. So typically when you're doing this in Python, when you make your many-to-many relationship, it will ask you to provide you the object that you want to relate to. So you'll have to provide Francisco and Python in those two. And then it will make the connection itself. Arjan?
So is it not common or to
instead of relating it by the ID, you could relate it to the name of the course and relate it to this name of the student?
No, that is not common. The main reason behind that is with students specifically, right? I mean, we've all seen it where many people have the same last name, right? Like I remember in my 41 platoon, we had like 30 something Rodriguez's. Then we had to come up with a different nickname for each one of them, so
Okay.
it all kind of depends on how many multiple records. You want to make sure that whatever you're making this connection to, it's going to be a unique ID.
Okay, that makes sense. Thank you.
Of course. All right. Any other questions regarding relationships? Relationships is a pretty heavy topic, so it's important that we understand it. Again, our one-to-one relationship is enforced by just having that foreign key being unique, right? We specified that integer to be unique. Our many-to-many relationship, the syntax is almost exactly the same, just missing that unique keyword. And then our many-to-many relationship is managed by a connecting table, which in this case we called course students. Any questions regarding relationships? Go ahead, Momo.
Yeah, just I want to know if there is any mechanism who can define if or this relationship or this relations, this tables will be many to many, have many to many relationships. You know what I mean? How is there any way to figure out if this will be many to many relationship or just if what I feel it makes sense for me?
Yeah, no, that's a great question. And that's definitely a popular thing where people, this is where the development of data engineering or like managing, building a new app kind of comes into concern, right? Is how do I build my relationships? How do I know when something is a one-to-one relationship? And a one-to-one relationship is actually probably the most straightforward one, right? It's like, oh, I'm only supposed to have one of these things for every one user. But where it gets a little bit confusing is once we start thinking about many to many and many to one. The way that I like to think about it is a backwards relationship, right? So the way that, for example, me as a person, I have many monitors, right? And I'm working on those many monitors right now. So for me, that is a one-to-many relationship because I need to know that one person has many or one monitors, right? Or don't need to know, but maybe that's what I want to know. But I don't necessarily need to know if my monitors are being managed by many people or if these monitors have multiple owners, right? Like as far as everyone knows, as soon as I hop off this computer, somebody else could be hopping on it and using it for a different purpose, and that would be a different owner. But that doesn't concern me, right? So as far as my application, what I'm creating, it's specific to what I'm building, right? What is it that I need to know from the user end for their relationships to be built? Does that make sense, Momo?
Yeah, thank you.
Of course.
Okay, I have another question.
Yeah, of course.
I read something about cardinality and participation, but I didn't understood it. It's related to also the relationship between the tables.
Okay. You said that there was a question regarding
Cardinality, yeah, and participation.
cardinalogy.
Cardinality.
Can you type it
Cardinal,
in? Can you type it in the chat, please, so I could see it?
yeah, it was just defining the kind of relationship between the tables. One of them is called participation, that define the relationship between the table, and the other one is called cardinality.
Hmm. I have to look at those two terms. I'm assuming that's in our curriculum somewhere.
No, I just was reading it, yeah, yesterday.
Oh, got it. You read it.
Is some technique to define, yeah,
Hmm.
the
I'll have-
relationship between the tables.
Yeah, I'll have to get familiar with those terms and get back to you because I don't know those terms off the top of my head. I apologize, Molo.
No, no problem, yeah, thank you. I just didn't understand it when I read it, yeah, thank you.
Of course. All right. Awesome. Well, that is going to conclude our relationships lecture. Today we covered constraints, the check constraint working with regex. We also covered how to cover different conditionals as far as in between, greater than or less than. We covered the null constraint and how to specify explicitly that something is not null, what the serial primary key is doing. And then we spent a good amount of time speaking about relationships, covering one-to-one, many-to-one, and many-to-many relationships. At this point, does anyone have any questions over anything we covered today? All right, if there aren't any questions, oh, I see something on the chat. Oh, that's from Len. Awesome. Thank you, Len. Appreciate it. All right, I'm gonna go ahead and stop our recording now.